Welcome. Today I am going to discuss some strategies to solve sentence equivalence questions. Today's class is Sentence Equivalence Strategy, Part 1 Introduction. Sentence equivalence is like single blank text completion. The only difference is there will be 6 options and 2 will be the correct answer. It is generally picked up from a published newspaper. Success on sentence equivalence questions depends on contextual understanding, strong vocabulary as well as word-using skills. So we can use 3 strategies to answer sentence equivalence questions. 1 context analysis, 2 option analysis, and 3 50-50 strategy. 1 context analysis. Know the direction. Sentence equivalence questions can go in the same direction and also can go in the opposite direction. We can refer to the same direction as the positive one and the opposite direction as a negative one. Be familiar with connectors. Know the correct grammatical use of connectors. Some connectors lead in the same direction and others go in the opposite direction. Know the math. Mathematically, sentence equivalence question has 2 parts, namely the blank part and without the blank part. Let's see an example. The macromolecule RNA is common to all living beings, and DNA, which is found in all organisms except some bacteria, is almost as dash. The first part, that means without blank part. The macromolecule RNA is common to all living beings. You have to think about without blank part, because this part will give you the clue about the answer. Second part, that means with blank part, and DNA, which is found in all organisms except some bacteria, is almost as dash. Let's understand the math. If the first part becomes positive, then the second part will be negative. That means first part plus multiply second part minus equals negative. If the first is negative, then the second part will be positive. That means first part minus multiply second part plus equals negative. If the first is negative, then the second part will be negative. That means first part minus multiply second part minus equals positive. If the first is positive, then the second part will be positive. That means first part positive multiply second part positive equals positive. With the above tricks, grammar helps you to understand complex sentence patterns. Let's read the above example again. The macromolecule RNA is common to all living beings, and DNA, which is found in all organisms except some bacteria, is almost as dash. The first part is talking about macromolecule RNA that is common or available to all, so available is the answer clue. The second part starts with and connectors that are used to link similar ideas, which is a relative pronoun that refers to DNA, which is found in all organisms except some bacteria. This part of the sentence is an apposition that tells us more about DNA. So, this part becomes DNA is almost as dash. Now, solve the prompt with the help of the tricks. Step 1. Read the entire sentence and try to figure out what the subject matter is here. This sentence is talking about macromolecule RNA and DNA. Step 2. Do not see the answer choices, try to find out the answer clue. You will find this clue in the without blank part. Step 3. What you have found common. Right. This will be your answer clue. Step 4. Are there any connectors? Figure out it. Here and is a connector that leads in the same direction. Final short. mRNA is common, DNA is dash. So the math will be common positive multiply and positive connectors equals positive. Now check the options. Find out positive pair or synonym of common. The macromolecule RNA is common to all living beings, and DNA, which is found in all organisms except some bacteria, is almost as dash. A. Comprehensive. B. Fundamental. C. Inclusive. D. Universal. E. Significant. F. Ubiquitous. Now check the relation. Can comprehension be common? No. So comprehension equal not common. Can fundamental be common? No. So fundamental equal not common. Can inclusive be common? No. So inclusive equal not common. Can universal be common? Yes. Make sense. So universal equals common. Can significant be common? No. So significant equal not common. Can ubiquitous be common? Yes. Make sense. So ubiquitous equals common. So the answer will be D and F.